Okay, let's simplify some radicals. Okay, when simplifying, what that means is you want to pull out from under the radical any perfect squares. Or if you break it down into prime factorization, any pairs. Okay, so A, if you notice this, 121, if you know your perfect squares, that is the square, or 11 squared. If you don't remember that, remember you're going to do the latter. 121 is not divisible by 1, 2, 3, 5, 7, but it is divisible by 11. So this is the opposite of the square root of 11 times 11, and we know that this is the opposite of 11. You have a pair underneath here. The square root of 0 is 0 because 0 times itself is 0. The square root of 45. 45 is not a perfect square, so I'm going to have to break it down. It's divisible by 3, which is also divisible by 3, and you get 5. So this is the square root of 3 times 3 times 5. So I've got, whoops, a pair of 3's that can come out, and I'm left inside with the square root of 5. 300 is not a perfect square, but let's see if we can break down 300. It's divisible by 2, divisible by 2, divisible by 3, divisible by 5. So this is actually the square root of 2 times 2 times 3 times 5 times 5. Okay, so I've got a pair of 2's, I've got a pair of 5's, and I have to leave the 3 inside, so this becomes 10 root 3. Okay, let's solve some equations. Now, when you look at an equation, you're going to have to look at it and think, okay, well, what exactly is it that I need to do? Is it linear? Is it quadratic like we did in radicals? Okay, so here, now you have the option, you can always clear the decimal. Since we can use calculators, I think that's a little goofy, but if you want to, that's fine. So I'm going to start by distributing. So this gives me 1.4 minus 0.7x is equal to 1.25 minus 0.5x. Okay, so this is linear, so I'm going to have to get the variables all on one side. It doesn't matter which side. It just doesn't matter. So I think what I'll do is I like to have the variables on the left. So negative 0.5x, negative 0.5, or plus, excuse me. And that gives me 1.4 minus 0.2x is equal to 1.25. Okay, so now I've got the x's on one side. I'm going to subtract 1.4, and that is going to give me negative 0.2x is equal to negative 0.15. And I'm going to divide by negative 0.2, and that gives me that x is equal to 0.75. Okay. Now we talked about clearing fractions. I'm going to tell you when I do these, if I'm going to clear the fractions, I want to do the distribution first. So the first thing I'm going to do is I will distribute. So this gives me 1 times 3 is 3. 6 times 4 is 24x. 2 times 1 is 2 over 6. is equal to negative 1 over 5. Now I can simplify this. 3 over 24 is 1 over 8x. This is 1/3 is equal to negative 1/5. Here I want to look for the least common multiple. Okay, so the LCM has to include the factors of 8, which are 2 times 2 times 2, the factors of 3, which is 3, and the factors of 5, which tells us the LCM is 120. So that means I'm going to multiply this entire equation by 120. So that means I'm going to multiply each of these by 120. So this gives me 120 over 8x minus 120 over 3 is equal to negative 120 over 5. That gives me 15x minus 40 is equal to negative 24. Here I'm going to add 40 to both sides. That gives me 15x is equal to 16. I'm going to divide by 15, and I get x is equal to 16 over 15. Now that turns out to be a repeating decimal, so just leave it as a fraction. Okay, no fractions, no decimals, yay. Let's see what happens. Okay, so the first thing I'm going to do is clean up this side. So I'm going to have to distribute my negative 4. So that gives me 7 minus 4x plus 4 is equal to 9 minus 5x. I'll combine my like terms over here. So that gives me 11 minus 4x is equal to 9 minus 5x. All right, so let's add 5x to both sides. That's going to give me 11 plus x is equal to 9. And now I will subtract 11, and I get that x is equal to negative 2. Okay. All right, let's go ahead and distribute on this one and see what happens. So I'm going to multiply everything here by negative 2, here by 6. So that gives me negative 2x plus 8 is equal to 6x plus 12 plus 3x. Everything here is fine. Here I need to combine my like terms. So I have negative 2x plus 8 is equal to 9x plus 12. Okay. You can put the variables on either side. I'm going to tell you, I'm going to add 2x to both sides on this one because then it makes it positive. But it doesn't matter. So I have 8 is equal to 11x plus 12. Subtract 12 from both sides, and I get negative 4 is 11x. Divide by 11, And I get finally that x is equal to negative 4 over 11. Okay, on E, let's see, on E, there are a couple ways that you can do this. You can use the square root principle, which means I'm going to take the square root of both sides. So that gives me that x is equal to the positive or negative square root of 25. Well, I know the square root of 25 is 5, so x is equal to positive or negative 5. If you're not comfortable with this, set it equal to 0. That would give you x squared minus 25 is equal to 0. Factors into x plus 5 times x minus 5 equals 0. So x is equal to positive or negative 5. Either way is fine, whatever you want to do with it. Okie dokie. Here I've got a rational expression. I have to get rid of the radical. So that means I have to find the LCM. Well, it has to have, let's see, 4x is equal to 2 times x, and x is just equal to x. So the LCM is 2 times x, which is 4x. So that means I'm going to multiply everything by 4x. So this gives me 4x over 1 times 3 over 4x plus 4x over 1 times 6 over x is equal to 4x times 1. Okay, well, 4x divided by 4x, those cancel or become 1. So 3, I can get rid of just the x here. Plus 24 is equal to 4x. Okay, combine my like terms here. So 27 is equal to 4x. If I divide both sides by 4, I get that x is equal to 27 over 4. Okay, gee, 2x squared plus 1 is equal to 19. I don't see perfect squares anywhere in here, but that doesn't mean there aren't any. But I think what I'll do is, since it's quadratic, I think I will start by subtracting 19 from both sides. So that gives me 2x squared minus 18 is equal to 0. Okay, this has a GCF of 2. So I'm left with 2 times x squared minus 9 is equal to 0. This, of course, is x to the second minus 3 to the second. So this becomes 2 times x plus 3 times x minus 3 is equal to 0. So each of these factors has to be equal to 0. With 2 equals 0, that can't happen. X plus 3 equals 0, so x equals negative 3. X minus 3 equals 0, so x equals 3. So there are your solutions. Okay, I'm going to do the same thing here. I've got a quadratic, which means that or it looks like a quadratic, so let's set it equal to 0. So the first thing I'll do is add 3x to both sides. So that gives me 5x squared plus 15x minus 20 is equal to 0. Okay, I see all of these are divisible by 5. So that gives me 5 times x squared plus 3x minus 4 equals 0. Okay, so I'm looking for, since my leading coefficient is 1, I'm looking for two numbers whose product is -4 and sum is 3. And that is, so those are 4 and -1. So this becomes 5 times x plus 4 times x minus 1 equals 0. Alright, so each of these factors, 5 equals 0, of course that can't happen. X plus 4 equals 0, so x equals -4. X minus 1 equals 0, which means x is 1. And there are your solutions. Okay, x times x plus 3 equals 10. All right, let's distribute, because it looks like it's going to be a quadratic. So x squared plus 3x is equal to 10. Let's subtract 10 from both sides. That gives me x squared plus 3x minus 10 is equal to 0. Okay, leading coefficient is 1, so I'm looking for two numbers whose product is -10 and whose sum is 3. They are 5 and -2. So this becomes x plus 5 times x minus 2 is equal to 0. So if x plus 5 equals 0, then x equals -5. If x minus 2 is 0, then x equals 2. And there are my solutions. Okay, got another quadratic here. Let's see, so x squared, let's set it equal to 0, so I'm going to subtract 7x and add 6. So that's going to give me x squared minus 7x plus 6 is 0. So from here, leading coefficient is 1. I'm looking for two numbers whose product is 6 and whose sum is -7, -1 and -6, -1 and -6. So this factors into x minus 1, x minus 6 equals 0. So x equals 1 or x equals 6 when you set each factor equal to 0. Okay, I'm going to quit here.